So good afternoon once again. So we will be discussing, this is our 4th session on bridge course, right? So we will be discussing today, we will be discussing periodic table and its classification. Okay. So before going to periodic table and its classification, so we have few more things to be discussed from the first chapter, that is what? Some basic concepts of chemistry. So this is completely, we have discussed about some basics related to physical chemistry. Okay. There are few things, 1 or 2 topics are there, so we will discuss them, then we will move for the periodic table, that is some basic concepts of inorganic chemistry, and after that I will be giving you some basic concepts of organic chemistry, like that. Okay. So in this session, I mean last class I have given you few questions. What about them? Have you seen now at least? Will you show after the class at least? Okay, so we will do remaining also, then we will discuss other important questions, I mean homework questions. Okay. So in the last class we have discussed up to here, right? So this is what, if we look at the masses, so it will be giving us, it is obeying law of conservation of mass. This is what in the last discussion we have did up to here. Okay. So let us start this one, percentage composition. For example, if someone asks you about, what is your mathematics marks out of total marks, how you will say the percentage of mathematics marks? So marks obtained in mathematics by total marks into 100. So this gives the percentage of mathematics marks compared to the overall marks, right? So here also, when I am giving you some compound, something like this, calcium carbonate I am giving, for simple one I will be taking calcium carbonate. Okay. So calcium carbonate I am taking. Okay. So this is a compound I am giving you. Okay. So now what is the mass percentage of calcium I am asking? Percentage weight of calcium in this calcium carbonate. Someone asks you like this. So what we need to take? So total mass, that is nothing but, total mass is nothing but total mass of what is this? Calcium carbonate. So total mass, that is nothing but the weight of calcium carbonate we should take, right? In the denominator, total mass you have to take. So what I am asking for calcium now. So here you can take mass of or weight of calcium. Percentage I am asking now. So this is how you can do, right? Is that clear or not? Yes. Now tell me, so let us consider this, its molar mass. What is the molar mass? For calcium it will be 40 plus carbon it is 12. For oxygen we have 3 oxygens into 16. So 48 plus 12 plus 40. So this gives us 100. So total mass is how much? 100. Now I am asking for calcium now. So what I should take? Weight of calcium. How much weight of calcium? 40. Total weight is how much? 100 into 100. So this one you can remove. So we are remaining with, what is the percentage of calcium here? 40%. Is that clear? If I ask you what is the percentage of carbon in this same species, tell me. Yes. So weight of carbon divided by total weight of compound into 100. So 12 by 100 into 100, that will be 12%. Is that clear? So that is what here I am giving. Percentage of element in a compound equals to mass of the element in the compound by total mass of the compound into 100. So this is how we will take percentage composition. This is in terms of weight. What I am saying, in terms of weight. Sometimes question will be asked in terms of moles, mole percentage. We will look into that example also. Okay. So you just write this formula in your notes, then give one example like this. Percentage weight of calcium is 40. Okay. So now I will be saying you few more things here. So same heading is percentage composition. What is our heading? percentage composition. Now I will be giving you a question here. Percentage composition of carbon in methane. Okay, so these percentage composition they can ask in two types. So one is weight percentage, second one is percentage mole or mole percentage they can ask. Okay, so based on same question, so for this methane only they have given in JEE mains once about percentage of mole. Okay, now how the question will be, see, now what I am asking, methane na, so weight percentage of methane, okay, let us say like this they will be giving. So what is the total weight of methane, now what is the molar mass of this methane? So for carbon it is 12, for hydrogen 4 into 1 for each hydrogen atomic weight, okay, so it will become 16 gram per mole is the molar mass of this methane. Is that clear or not? Yeah, so like this you can take. Okay, so now I am asking about carbon percentage by weight, okay. So now what I can say, percentage of carbon means what I should take, weight of carbon by molar mass, that is what total weight will write, total weight into 100. Okay, let us zoom it out. Okay, so like this we can write. Okay, so now what is the weight of carbon? 12 by 16 into 100. So it will be 4 3s are 4 4s are 4 1s are 4 25s. So what is the percentage of carbon? 725 into 3. So I can write 75%. This is by weight percentage. This is what? By mass or by weight percentage you should say. Now if I ask you for what is the percentage of hydrogen by weight? For the same question I am asking for hydrogen. 4 by 16 into 100. So that will be 25% you will get. Okay, simply see here, this compound is made up of carbon and hydrogen only now. If carbon weight is 75%, remaining will be the weight of hydrogen only now. That's it. So 75, 100 minus 75, that is what, 25, that is what for the hydrogen. Like that also you can understand. Okay. Now one more thing here I am asking is for a mole percentage. So say for the same question I am asking percentage by mole. Okay. So now if I say 1 mole methane, what I am saying, 1 mole methane contains how many moles of carbons? See, 1 molecule of methane, if I say, we have 1 carbon atom, 4 hydrogen atom. So now if I say 1 mole of methane, it means it contains 1 mole carbon atoms and 4 mole hydrogen atoms. Yes or no? So now total moles how many? 5. Total moles 5 moles. Total 5 moles like this. Now I am asking percentage of carbon by mole. What we should take? Number of moles of carbon by total number of moles into 100. Number of moles of carbon how many? 1 divided by 5 into 100. So it will be 220. So 20%. See, answer is different. Percentage of carbon by weight is 75%. Percentage of carbon by mole is 20%. Both answers are different now. So in the exam, examiner may give whatever he wants to ask you, but both options he may include. So you should be very clear what they are asking exactly. Is that clear or not? Yeah. So one more thing here, if I ask for hydrogen, what is your answer? Percentage of hydrogen by mole. 4 by 5 into 100. So that will become 4 by 5 means 20 into 4, that is 80%. How much? 80%. Otherwise 100 minus 20 gives 80, na? That is for hydrogen. Is that clear or not? Yeah. So you can make a note of it. Yes. So let's discuss few more things. So I will be giving you one question. Percentage of carbon in acetic acid. Percentage of carbon in acetic acid. Percentage of carbon in acetic acid. So consider here it is weight percentage. Okay, this is the homework question. Let's move further. Good morning, sir. Good afternoon, Faith Lens. Who is this? It is good afternoon, na? I think you woke up now only. Yes, done. Let's move further. So before going to start periodic table, let's have one more discussion. This is again very important. So I will be giving you some basic idea on stoichiometry calculation. In detail, we will study in the complete lecture. Okay, in real class. I mean in the full chapter we will study. Here we will have some basic idea. So now stoichiometry, it means the name here we have stoichiometry. Na, it means elements measure. It means what exactly? During chemical reactions, elements like reactants will combine to form products. Na? So in order to form some particular amount of product, so how much amount of reactant should combine? Or for example, I have 5 grams of A and 10 grams of B. So how many grams of C is formed? Like that. Or how many grams of D is formed during this reaction? So these things we will be calculating using this stoichiometry. Okay. So now see, stoichiometry is a branch of chemistry, deals with the quantitative. It means how much quantity is formed, quantitative relations between reactants and products in a balanced chemical reaction. Okay. It means first of all, in order to use this method, first of all, what is the main criteria? We need to write the symbolic chemical equation and balance it by following law of conservation of mass. Okay. So now using this we can calculate mass-mass relation. It means for example A plus B giving rise to C plus D. Okay, these are the products formed from combination of these reactants. Now if I take 5 grams of A and 2 grams of B, how many grams of C is formed? Like that we can calculate, that is what the mass-mass ratio or calculation. And we can also calculate, if I say 2 moles of B, 5 moles of A combining, then how many moles of C and D are formed? So that is what mole-mole ratio. Okay, and we can also calculate mole volume ratio, mass volume ratio, that is what I have mentioned here. Okay, and one more concept is there, that is what limiting reagent, excess reagent concept. We will be discussing about that in the upcoming sessions. Okay, so let us start the basic understanding here. So what are the key concept I told you? So one thing is you need to balance the chemical equation, then you have to take mole ratio. It means stoichiometric coefficients will be there, their ratio you have to take. I will show you. For example, here for formation of water, here I have mentioned H2 plus O2 combining to form H2O. So first of all, writing the chemical equation, symbolic chemical equation. Then next what I told you, then we need to balance the equation. Is this balanced or not? This is not balanced now. How many hydrogens? Here oxygens 1. It is not balanced. So how can we balance? See, I am multiplying here with 2, here with 1 and here with 2. Now check, 2 to the 4, 2 to the 4 hydrogens balanced, 2 oxygens, 2 oxygens. Yes, everything is balanced. Now what is their mole ratio? See, mole ratio is nothing but its stoichiometric coefficients are there na. So these coefficients are there na, those are called stoichiometric coefficients. Okay, so this is 2, this is 1 and here 2. It means when 2 moles of H2 combining with 1 mole of oxygen forms 2 moles of water. Is that clear? Now this is about mole ratio. Okay, now I will be giving you one question. Now I have 4 moles of hydrogen, okay, 4 moles of hydrogen combining with 2 moles of oxygen, then how many moles of water is formed? Easy, very easy question. See, this is the ratio we got from its balanced equation. Now I am giving you 4 moles of water, hydrogen and 2 moles of oxygen I am giving, then how many moles of water it is forming? Very simple question, just use this relation in order to get this answer. 4. Why it is 4, you tell me? See, for every 2 mole we required 1 mole. For me it means for every 4 moles we required 2 moles. See, 2 2 ja 4 na. So by using this mole ratio, the balanced chemical equation, stoichiometric coefficients, we can get how many moles of these things are combining to get this product. Is that clear? Now I am giving you 8 moles of hydrogen, okay, and then next 8 moles of oxygen, then how many moles of water is formed? Very easy again. Just think. So dear students who are in online, I mean live session, so just you can also answer in the chat box so that I will be verifying your answer whether it is going correct or not. See, for every 2 moles, how many moles of oxygen is required? 1 mole. It means for 2 moles we require 1. It means half of this. 2 means it is 1. So for 8 means how many it is required? 4 is enough. But we have 8 now. So it means this is more than our requirement. So we can say this as excess reagent. What is that? See, how much we required? We just required 4 moles. And remaining 4 moles will be remains unreacted. So out of this 8 moles, see, for every 2 moles we required 1, means for 8 required only 4 is reacting. So 8 reacting with 4 and forming how many moles of water? See, for every 2 it is also 2, for every 8 it is also 8. Is that clear? Now out of this how many moles of oxygen is reacted? So still 4 moles is remaining unreacted. So after completing the reaction, what we are having now? So this is completely reacting now. So after reaction, after complete reaction, so what we are remaining with is anything, H2 is remaining left, anything is left? No, 0 moles. What about this? 4 moles reacted, 4 moles remaining, right? 4 moles I am writing. How many moles of product formed? 8 moles of product formed. Like this we need to write. Ardhamainda kaleda. Is that clear or not? Yes. You can make the note. Yes, let us discuss few more things if you are clear with this. Now 2 moles of hydrogen means what is its molar mass? See, for each hydrogen we know 1, 2 hydrogen, H2 means 2. So molecular weight of H2 will be 2. 2 into, here we have 2 now. So 4 moles react with 1 mole of O2 means 32 grams in order to get this 36 grams. It means I will be giving you one question. So you can try this question. 2 grams of H2 reacting with 16 grams of O2 to form X grams of water. Then value of X. Is that clear? Question is clear now? So just make this question, write in your books and tell me answer after the class. Or online students, you can write in the comment box if you know the answer. Done? Okay. So now see here, what mass of CO2 is produced when 12 grams of carbon is burned. So take carbon. So how can we do? Burning means we require oxygen. So that complete combustion gives what? CO2. Now see what is, whether equation is balanced or not. First of all, what is the primary condition? Write the equation, balance it. Carbon, 1 carbon, 1 carbon, 2 oxygen, 2 oxygen, balanced. So 1 mole of this carbon reacting with 1 mole of this oxygen forming 1 mole of this CO2. Everything is balanced, right? Now 1 mole carbon means what is its weight? 12 grams. In the question also they have mentioned 12 grams. Okay, 12 grams. Okay, so this 12 grams reacting with 1 mole of oxygen. 1 mole of oxygen means what is the weight? 32 grams. Okay, then what is the weight of CO2 formed? So 1 mole of CO2 means what is its molar mass? 12 plus 32, 44 grams. That's it, your answer. Or if you want to cross check it, we know law of conservation of mass now. So reactant side how much mass we have? 2 plus 2, 4, 3 plus 1, 4, 44. So reactant side and product side mass is same. So our reaction and everything is going correct only. Is that clear or not? Yeah. Now I will be giving you one question. Okay, to the same thing. So I am changing this number. I think this question is clear now. So here I am taking, instead of taking 12, I am asking you to do it for 36 grams of carbon. So 36 grams of carbon is reacted here. Then what is the mass of CO2 produced? Make a question and answer it. Done? 36 means what? Simple, you just take here 36 and try to do it. So 12 grams require 32. 36 grams require how many? 12 3 is 36 now. So it means this is also multiply with 3. You will get some number here. So just add those two numbers. You will get this answer. Otherwise, there are many simplest ways. See 36 grams now. So 12 grams means 1 mole. So 36 gram means 3 moles. So 3 mole, 1 mole forming 1 mole of CO2. 3 moles will form 3 moles of CO2. So 3 into 44. Like that also you will get the answer. Is that clear or not? Yeah. 130? Yeah. Done? Are you feeling it is very low, like very easy questions? I can increase the I mean level of questions, difficulty level of the questions. If you feel very easy, you just tell me, I will increase the level of hardness. Okay, I am considering that these are very bridge course, very basic, that is why I am giving very basic questions. If you want, I can increase the level, I mean little more, let us say. This question is clear now? Yeah. Given 12 grams of carbon and not 12, let us say 48 grams of carbon and 64 grams of oxygen upon combustion, upon complete combustion forms X grams of CO2. You can tell me this answer. So you can write this question and you can tell me the answer. What is the value of X here? Here also same. What is the value of X? Okay. So it means, what is the first step? Write the equation, balance the equation, find their mole ratio. Okay. So for each mole of carbon, what is its weight, and that weight and this weight, how these two are related, from that you can get the answer. Clear now? Now tell me, how many moles of NaCl are formed when 2 moles of NaOH and 2 moles of HCl is reacted? See, this is the equation we can write for NaOH plus HCl. So in the question I am giving 2 moles of NaOH and 2 moles of HCl I am giving. Then how many moles of HCl is formed? First thing is, write the balanced equation, find their mole ratio, from that you can interlink the given data. So NaOH plus HCl, very basic questions these are, NaCl plus H2O. See, 1 mole combining with 1 mole HCl forming 1 mole NaCl. See whether the elements, all the things are balanced or not. See, 2 hydrogens, 1 oxygen, 1 Na plus, 1 Na plus, 1 Cl minus, 1 Cl minus. That's it, everything is balanced. Okay. So mole ratio is 1, 1, 1, 1. This is a mole ratio, but in the question what they are giving? 2 moles of HCl and 2 moles of NaOH. Okay, moles of HCl and NaOH is given. So this is 2 moles, this is also 2 moles. Now tell me, how many moles of NaCl is formed? This is also 2 moles, this is also 2 moles. Easy only, na? Now instead of asking how many moles of NaCl formed, they simply ask what is the weight of NaCl formed. Weight of NaCl. Tell me, how can we do? We got moles now. Convert moles into its weight. How can we convert? Number of moles equals to weight by molar mass. So we want weight. It means send this molar mass into this side. Number of moles into its molar mass gives weight. Number of moles is 2, and what is its molar mass? This is 23 plus this is 35.5. So it is 58.5. That will give us what is the weight of NaCl formed. Is that clear or not? One more thing. If they ask for water, what is the weight of water formed? 2 into its molar mass. What is its molar mass? 18. See, for very basic things, something like, see, what water, carbon, methane, these are very daily we are using, we will be very familiar with that. So you should not think about that also. So water means you should have one fixed number, 18 is the molar mass of water, like that. So when you are doing the calculation, you have to keep it in your mind for basic things, for glucose also. See, C6H12O6, again if you take your pen and doing again and again means it will kill your time in the exam. So if you remember it as 180, that will be good. For methane 16, like that. For CO2 44. So just by calculation only we will get, but you need to remember them. While doing the numerical it will be more easy. Okay, we can save the time. Yes. Now let us start our topic, periodic table and its classification. So now why do we need to make a table of these elements? So what is periodic table? It is a systematic arrangement of elements, right, according to their like having those elements which are having similar properties are arranged together, like that we are doing. So but what is the requirement of doing that? See, when we are going to any library, so if the books are arranged very randomly, it is very difficult to take the one which we require, right? But if they segregated according to the like requirement, I mean category wise, for example all medicine books at one side, all physics book another side, and chemistry books one another side, if they put like that, so we can directly go to the section which we required and we can directly pick that. So here also if the elements having similar properties are kept together, so it is easy to study them, easy to analyze them, na? So that is the main agenda, to keep the elements in the periodic table in the systematic arrangement. Okay, that is what the classification they have did for. Okay, so now different scientists came with different approaches. Okay, so we have different classifications here. So first one is Daubernier came with Daubernier triads. Okay, so after that we have Newland's law of octave. Okay, we will study about this thing. And next Luther-Meyer classification we have curve, he has taken. Mendeleev classification we have. The next modern periodic table, this is what we are presently following, right? So now this is how the development occurs. So no one have complete knowledge, I mean for any on particular thing, everyone will be having their own improvements, or by looking at the drawbacks other will get improved, right? So by looking at the drawbacks of one other, the things are going improved, right? So now first of all Daubernier triads. So what he is going to explain here. So triad means it is a set of 3 elements. Okay, what he has taken is, so he has taken 3 elements. For these 3 elements he has considered increasing order of their atomic weight. What he consider? Atomic weight. Let us say element A, element B, element C are there. So this is the arrangement of their increasing order of their atomic weight. Now the atomic weight of the middle element, it means atomic weight of B, atomic weight of B is average atomic weight of A plus atomic weight of C, A plus C by 2. This is how we are doing the average, na? So atomic weight of B is central atom is equals to average of first and third element. So this is what he analyzed, or whatever he got the output. Okay, so like that, so he did it for lithium, sodium, potassium. See, lithium is having 7, potassium is having 39, 7 plus 39 by 2 you will be getting this 23, right? So now this triad was applicable only for few set of elements. Okay, it was not applicable to the all the elements which were known at that time itself. So it means if he was unable to explain it is applicable only for few elements, why not to the all elements? So that's how it got failed. Okay, so this is the triads, you have to remember them. Clear now? Okay. So what is the drawback? Only for few elements it is working. Clear now? What is the thing he has taken? He taken set of 3 elements, called it as triads. He arranged them increasing order of their atomic weights. Now middle element will be having the average of first and third element. That's it. Next, Newland's law of octave. So you know musical note, you know na, sarigama padanisa, like that. Okay. So now every first and 8th element, when he consider the elements in the increasing order of their atomic weights, this guy also consider atomic weight only. Now arrange the elements in the increasing order of their atomic weights. So now for every first element and the 8th element he has observed same properties. Okay. So when the lighter elements known at that time are arranged in the order of increasing of their atomic mass, then after every 8th element there is a repetition in the properties, like 8th note of a musical scale. Okay. So drawback also we have. So let us see once. Okay, see here lithium we have. After lithium 1, 2, 3, 4, 5, 6, 7 means 1, 2, 3, 4, 5, 6, 7, 8. So see here right now. So lithium and sodium both are alkali metals now. Now they will be having similar properties. Similarly beryllium and magnesium, here we have like that. Okay, so now if you observe this properly, there is no noble gas in this. Check once, is there any noble gas mentioned? So when this Newland is giving his Newland's law of octave, noble gases were not introduced. Okay, so now if noble gas is introduced, so what happens? See, after fluorine, here we will be having noble gas, neon will be there. So if no noble gas is there, what is the repetition number? First and 8th. If noble gases are inserted, first and 9th it should be. Okay, when he proposed it is, there is no noble gases in the classification. That's why we got first and 8th. Okay. Now this is also, what is the drawback? Applicable only for lighter elements having atomic number up to 40. So therefore this is also not up to the mark, means not explain all the elements known, right? So this is the drawback. Okay, then next we have, okay, we will go to Mendeleev. Before that you tell me answer for these questions. Easy answers, tell me what are the answers we have. Robonier triad consisted a group of 3. Next, 6 and 8. Then atomic mass of second is how much? What? 6 plus 18 by 2. How much? 24 by 2, 12. Easy only, na? Yeah. So next, according to Newlands, which element had properties similar to boron? Yes, tell me. Boron and aluminium, right? Next, so for this you just write the elements. The 8th element will be aluminium again. Next, for this, Moseless, we will study about this Moseless. So so next we have Mendeleev. Okay. So what he is saying, Mendeleev for the first time he given periodic table by formulating a periodic law. So by considering a law, he given the classification. So what he told, the properties of elements are the periodic functions of their atomic masses. Okay, it means he arranged based on their atomic masses, increasing order of their atomic masses. Okay, so Mendeleev periodic table contains vertical columns called groups. It means vertical means like this. So those are called columns. Columns here we are calling it as groups. Okay, so these vertical columns are called groups. Okay, and we will also having something like this, horizontal rows are called periods. Okay, over. Next, so now what are the drawbacks here in this classification? So no fixed position for hydrogen. So in the periodic table if we consider, hydrogen is mentioned somewhere here, I mean along with the alkali metals, but that is not the exact position. Till now there is no accurate position for the hydrogen. Okay, so now why it is? Because see, hydrogen will be having similarities with the alkali metals as well as with the halogens. With which groups? Halogens and alkali metals. Alkali metals means this lithium, sodium, potassium are there now. So with that, why? Because what is the general electronic configuration we are writing for first group element? Sodium will be writing 3s1 valency, for potassium 4s1, for hydrogen also, for lithium we are writing 2s1, for hydrogen we are writing 1s1, like this now. Yes or no? So now if you see the configuration, it will be something like this, having similarities. Now if you say noble gases also, now if we fill one electron in this hydrogen, so if I fill the one electron in hydrogen, it will get noble gas configuration. That is what? Helium gas configuration. Na? What is the helium gas configuration? 1s2, right? So it is something like fluorine. You tell me what is the fluorine electronic configuration? This is no halogen, na? Fluorine means. Tell me. 1s2, 2s2, 2s2, 2p, 5. If we give one electron, one more electron, it will become, after this fluorine what we have, it is 9, then 10 is neon. Helium gas, neon gas configuration, inert gas configuration it is getting. Similar to halogens, our hydrogen is also getting, by taking one electron it is also getting inert gas configuration, right? So that's why it is having similarities with the alkali metals and as well as halogens. Therefore, its position was not yet fixed. Okay, so sometimes we will be see the hydrogen at the top of the periodic table. So that will be middle at the top of the table, not with the alkali metals, not with the halogens. Okay, next, see what are isotopes, you tell me? Isotopes means species with same atomic number, same number of protons but different mass number. So it means, for example, carbon isotopes you are saying C12, C13 and C14 we are saying. Na? So now see here whether they are having same mass or different masses. Mass number is different now, here 12, 13, 14 means different numbers. Okay. So now if the mass number is different, the 3 isotopes should be separately arranged now, but he given only one position for all the carbon atoms. He was not given different positions for isotopes. See, Mendeleev classification is based on atomic masses and Luna. If mass is different, the position of isotopes should also be different, but all these are placed in the one position. But there is no reason, there is no explanation from him for this. So this is also a drawback. Is that clear? And the next, some elements having anomalous pairs. It means, what is his basic periodic law? He arranged based on the increasing order of their, if atomic mass increases, so elements should be increased accordingly to the increasing atomic mass. But few elements are there with lower atomic mass will be occupying the front position and higher atomic mass back position, which is called as anomalous pairs. So like these few elements are there, so this reason for this also he was unable to explain. Okay, these are the drawbacks. Okay, next. Okay, next we have modern periodic table given by Moseley's. Okay, so Henry Moseley, what he is saying, showed that atomic number of an element is more fundamental property than its atomic mass. Okay, he has taken some X-ray diffraction method. Okay, then he concluded this thing. Okay, now what is the fundamental thing here? He considered fundamental property is what? Atomic number, not the atomic mass. Okay, so now the properties of elements are the periodic function of their atomic numbers. Okay, so modern periodic table has how many vertical columns? 18. These are called groups, and 7 horizontal rows called periods. So how many rows are there? 7 horizontal rows, we are calling them as periods. And how many groups are there? 18 groups are there like this. Okay, now the first period contains 2 elements like hydrogen and helium, we have now like that. Okay, then next, that is the shortest period in the periodic table. Okay, very shortest period. Then next, the subsequent periods consist of 8 elements, second period elements, 8 elements are there. Then next, what we have? 18, and the next 32, like that we will be having. Okay, 7th period is incomplete. In NCERT it will be mentioned incomplete, but as of now in the current periodic table all the elements are known. So totally how many elements we have now? 118 elements are known. Okay, so this is the periodic table we have. See, all the elements are known now. If you see in the NCERT book, so here some elements will not be mentioned, their names, they just give IUPAC nomenclature, right? But all the elements are known as of now. I mean in the periodic table, I mean here 118 elements. Okay, so now, so these are first group elements, these are second group elements. Okay, now you know there are 2 types of classification, like this Mendeleev classification he told now. So he told this as 1A elements, 1A, 2A. Okay, this is 3A, 4A, 5A, 6A, 7A, like that. Okay, so now, and this is 1B, this is 2B, and from here 3B, like that we have Mendeleev classification. But when it comes to IUPAC nomenclature, IUPAC standards, so what he told is, consider it as number 1, start the numbering from here, so directly give number without any exceptions, like 1, 2, 3, 4, 5, 6, like that. So we will be having up to 18 vertical columns, which we are calling it as groups. 18 groups are there. Now see, these horizontal rows are how many are there? 7 are there. So 7 horizontal rows we are calling it as periods. Now these are first 2 groups are what? These 2 series are S block elements, and these are P block elements, and this is D block elements, and these are F block. Now my question is, this F block elements belongs to which group? Which group these F block elements are lies, in which group? See here, this lanthanum is there na, here you are seeing. Here you are seeing lanthanum, right? So lanthanum continues with this lanthanides. In this lanthanum itself, these elements will lies. Okay, here we have actinum now. So this actinum contains these actinides. So now actinides, lanthanides and actinides belongs to which group of periodic table? That belongs to this group now. What is the group number? Third group you can say. So what is the group number of lanthanides? Yes, Nandu Medico, NEET aspirant. Is it you? No. Good afternoon, Nandu. Yes, tell me. So these are belongs to lanthanide, belongs to this series. It means which group it is? Third group. Okay, if they ask according to Mendeleev, you should say third B group. Okay, 3B, or simply 3. Now which period this lanthanide belongs to? 6. Actinide belongs to? 7. You can understand like that. Is that clear? Yeah. Next thing is, so these are metals. As we grow from here to here, metallic nature decreases and non-metals are this side. So metals from here to here, this yellow line series is there now, that is metalloids, and these are non-metals. Is that clear or not? Yes. Trends in the periodic table. So first one is valency. So what do we mean by valency? What do we mean by valency? So valency is given by number of elements given in the particular element. For example, 13th group elements are there, boron family elements are there. What is its electronic configuration? Boron is atomic number is 5, so you can write 1s2, 2s2, 2p1, right? See, 5 electrons are there now. So these are called highest energy level electrons are there now. So these are called valency electrons or outermost shell electrons. Only these outermost shell electrons will participate in the chemical reactions. So now how many electrons are there in the outermost? 3 electrons are there. So these are the number of valency electrons, you can say 3. Okay. So like that for carbon we have 4. Okay. So now carbon can form how many bonds now? It has 4 valency electrons, so it can make 4 bonds with that. Okay. So now valency of element is determined by the number of valency electrons. Okay. In a group, valency remains the same. It means for 13th group elements like boron family. So what are the elements? Boron, aluminium, gallium, indium, thallium. Like this we have elements now. So for all the elements, valency will remain same. Okay. For complete carbon family, valency will remain same like that. If they take elements in particular group, the valency will remain same. Clear now? Next, in a period, valency increases up to 4 and then decreases. It means for first group elements, second group elements, second period elements, if we consider, what are the elements we have? Lithium, beryllium, tell me, boron, carbon, nitrogen, oxygen, fluorine, like that we can write. So here maximum valency electrons we will be seeing here, which are participating will be 4 here. Okay. So now for this we have NS2 NP5, valence electrons are 5 are there, so it can make 3 unpaired electrons and 2 are paired. Like what is electronic configuration? NS2 NP3, like that we have. Okay. So by this it can make 3 bonds, like ammonia, you know now, ammonia, like that. Okay. So this will be present as lone pair electrons like that. Okay. That is what here mentioned as 4. Then next what about atomic size? See, down the group what happens? See, I am writing lithium, next sodium, next potassium, like this we will be writing now. So down the group what happens is, so valence electronic configuration you tell me for this, this is 2s1, this is 3s1, this is 4s1, like this S1 remains the same, but these coefficients 2 2, 3, 4, the numbers increasing now. These numbers are called shell numbers. What is that? These shell numbers are increasing. So that is also called as principal quantum number. What is that? So as principal quantum number increases, it means if this is the atom, this is the nucleus of atom, okay. So these are the shells. See, as number of shells increases, size also, this is first shell, second shell, third shell, shell number increases, size also increasing. So number of shells, okay, so atomic size increases directly proportional to number of shell. So down the group, what happens to the atomic size? Increases. In a group, atomic size increases down the group. Yes or no? In a period, atomic size decreases across the period. Why it is decreases? So tell me, why it is decreases? Nandu, last shell, and which is participate in bond formation. Yeah. Yes, tell me. See, if you take the period elements, like what are the elements? Boron, carbon, if we say, nitrogen, are they belongs to same group, same period or not? Which period elements these are? Second period. So for this I am writing 2s2, 2p1. For this I am writing 2s2, 2p2. For this I am writing 2s2, 2p3. If you observe here, number, here if you see for this group elements, number is increasing here, 2, 3, 4 it is becoming, but here this number is being same. It means electron is entering into the same level, same shell. It means that if electrons are increasing from here to here, atomic number is 5, 6, 7 like that. It means inside protons also increasing now, it means positive charge also increasing now. So electrons are lying in the same shell and inside positive charge is increasing, therefore they attract the electrons very close towards itself, therefore size what happens? Decreases. So across the period what happens? Size decreases. That is what I mentioned there. Clear now? Yes. Okay. Then next, few more things. I will ask you a few more things. What about electronegativity? What do you know about electronegativity? Hello sir, 26th na EAP set exam undi, so please give cheat codes for that. So Srinivas, so I always suggest my students to follow concept rather than these cheat codes. So I don't believe much in cheat codes, but you can make your own tricks by analyzing the papers. See, we have already made few analysis papers, just follow those. I mean, see, I have taken EAP set 2025 Telangana papers. I have discussed almost 4-5 question papers from this 2025 EAP set, okay, Telangana EAP set. So these are very useful for you if you are really going to attempt seriously for this AP EAP set. Because AP exams are really relatively easy when we compare with the Telangana EAP set as per this 2025 papers. Okay, so you can, even if you ask your friends, they will be saying that 2025 AP EAP set papers are really going easy. Okay, so I suggest you to follow Telangana EAP set 2025 papers at this moment, so that you can revise the topics very quickly and you can make more clarity on your preparation. Okay, so when it comes to, so please stop repeatedly you are saying same message now. Then there is nothing like cheat codes which definitely works. It all depends on your luck if you follow cheat codes only. Okay, so there is nothing to say about cheat codes here, and so at least you focus on few important and easy topics at this moment rather than these cheat codes. Yeah. Then next we will be what we are discussing, electronegativity. So what is this electronegativity? For example, we have element A and element B, we have two elements. Okay, so let us say there is a bond between them and we will call it as covalent bond. Okay, so now depending upon the their ability to attract this bond, See, now one element might be having more tendency to attract this bond and one is having low tendency. Okay. Now the element which having more tendency to attract the bonded pair electrons towards itself is called its electronegativity. What is electronegativity? Tendency to attract the bonded pair electrons towards itself. Okay. So now halogens will be having more electronegative than the other elements, right, generally. So what is the highest electronegative element in the periodic table? Fluorine. After fluorine, oxygen. Okay. So now here as we move this side, electronegativity decreases. Okay. As we go down the group also, electronegativity decreases. So can I say from left to right, electronegativity increases from S black to P black, electronegativity increases. So S block elements are what? Metals now. Metals are electropositive. Okay. So those are electropositive. Here we have P block elements, we have non-metals which are electronegative. Okay. The bond between metal and non-metal is what? Electronegative element and electropositive element will be generally ionic bond, we can say. So why I am saying, see, electropositive metal you can say sodium, electronegative element you can say chlorine. What is the bond between them? It is an ionic bond, no? So that's how you can understand the concept. Okay. So this is about the basic understanding of periodic table, and you know we have few more properties to discuss. We'll do that in the next class. So next, Srinivas, tell me the important chapters. See, again I have made 3 videos, top 30 questions for physical as well as inorganic and organic. Okay. So you just go through these questions, and you know I made a separate session for GOC. So for complete organic you can just go through this GOC part, and then next refer hydrocarbons. Okay. So these are the important topics from the organic chemistry. Okay. Then next, when it comes to physical, first of all you watch this top 30 questions of all these 3 subjects. Okay. That will be best at this moment. And then next, for physical you can just go through the mole concept. We already discussed concentration terms, I have already discussed in the playlist, it will be there, everything will be there. Okay. After doing that, you can also go through structure of atom. So you can see 1 or 2 questions in structure of atom. Srinivas, especially for you. Yeah. Then next you can go through solutions from second year. So after studying this, you can also see equilibrium, that pH based questions. Okay. So these are the important topics. So just go through our playlist. I have already covered all these important topics and important chapter for your exam preparation. Okay. So you can even go through metal complexes, coordination complexes also. Is it possible to study all the subjects in 2 days? How it is possible, man? Okay. So thanks for the session. So if no doubts, I can wind up the class.